So how we're going to start is we're going to identify the types of transformations. So we have translations, and I'm going to make this a little bit smaller here, and I'm going to make it red. 10. I'll bring this over here. So we have translations. So these are our sliding. This is sliding. And in general, we're going to look at it in general, and then we're going to look at it with an equation. So let's say we have f of x, right? And if I'm transitioning towards the left, if I'm moving left, I'm going to, if I'm sliding left, I'm going to say f of x plus h. And that's with the general way we look at a function. But let's say we have y equals the absolute value of x. Then if I wanted to move to the left, moving left 3 units, I would say y equals the absolute value of x plus 3. So I'm going to add to both sides. So let's say I want to move right? So it will be f of x minus h. That's in general, right? Function in general. But let's say we're working with that absolute value. Then I would have y equals absolute value of x minus 3. Okay, what about up and down? Up and down. So up, we have f of x plus h. So it's not inside the parentheses. It's not inside the function itself. So if I'm moving absolute value up 3 units, I would have the absolute value of x plus 3. And notice the difference between moving left and right versus moving up and down, right? So up and down, my number is outside of this function. Okay, absolute value of x minus 3. Now, let's look at what we'll call reflections. So how might we view reflections, right? So our original is f of x. So with the reflection over the x-axis, or I might say up and down. Sometimes it's just going to be negative f of x. Right? We flip it over. If I were going to do the equation absolute value of x, then it would be y equals negative of the absolute value of x. All right. Over the y-axis, and this one is interesting because it's so side to side. Let's do left to right. So this in general, it would be negative f of f of negative x, right? So here, that would be y equals negative x, okay? Now, lastly, we want to look at dilations, all right? We have a vertical stretch, so that's when I have a number times, and the way we look at dilations, I want to say in general, we have a number, the absolute value of that number, it needs to be greater than 1. So if I have a times f of x, it's a vertical stretch, first of all, or vertical stretch or vertical shrink. If it's greater than 1, any number greater than, absolute value is greater than 1, I could do negative 3, so I could do negative 2, absolute value of x. The absolute value of negative 2 for my number is greater than 1. 2 is greater than 1. Or I could even say, I could say 3 absolute, say 3.5 for absolute value of x. Either of those is a vertical stretch. So that means it gets closer to the y-axis. So a vertical shrinking, same thing, a f of x. And here, my number is less than the absolute value. So like 0.5 absolute value of x, or 1/4 absolute value of x. I can typically tell if the number is less than 1. Less than 1, but it's still positive, right? There is the horizontal stretch and shrink, but we'll get to that, and I will move on to these problems over here. So here we have x squared plus 2, and these look like shifts, like sliding only. So it's outside, and this is going to be slides up 2 units from the parent function. Look at this next one. It's inside, it's added, so it slides left 4 units. Right here slides right 3 units. And then it slides up 4 units. Okay? Last, we slide left 3 units. And then we slide down 2 units. Okay? And that takes care of everything for you. I'm going to stop it right there. And the next video looks at reflections. So I'm going to copy the bottom portion over. So you might want to do the same, and you'll see it when our video starts.